In my video yesterday, I talked about network latencies and database performance. I want to continue the discussion from where I left off and take an example. So let's say you're hungry, you're looking for food to eat, and you're looking for either a restaurant or a grocery store, right? Let's write a simple requirement. If you can find food at a restaurant, you want it to be in a zip code. I'm just randomly creating one. Maybe there is such a zip code, maybe there isn't. But if I cannot find one in that zip code, I want to go look for Chinese food, right? Which is one of our favorite cuisines. So I'm just going to write that here. If I don't find that, right, if none of this happens to be true, then I want to go with my second option, which is essentially picking a grocery store, which also happens to be in the same zip code, or it actually has Indian groceries, right? It has an Indian section, for instance. So let's call it has Indian, a Boolean, right? So if one of this is true, I either want to go to a restaurant that's in this zip code or that has Chinese food, my first preference in that order. Or if I don't find that, I want to go look for a grocery store in the zip code. If I cannot find one, then I don't mind driving a bit further so I can buy some Indian groceries and bring it home and cook, or just beg and plead with my wife so she could do it, right? Now that's my requirement. Now let's say we write some queries for it, and again, a lot of this is like pseudocode. It's not specific to any language, but it might still, depending on whatever I last wrote code in this afternoon, some of it might find its way here. So just excuse me for that, right? So let's say I write a query that says restaurant dot where, sorry, yep, zip code. Handwriting is extremely poor. Zip code is this, right? I could say that is empty, right? So because if it's Mongoid, it's going to return null, so I just check for empty, but you can ignore this part. I have to do a dot not empty, or I'm going to say restaurant where cuisine, assuming that's the name of your attribute or column. You'll probably do a case insensitive check here, but again, doesn't matter for our use case, right? It's not empty, right? So something like this. Or in that order, I'm going to say, oops, it's uppercase G. Just read it as though it's uppercase, where once again, it's zip code. This part's not different. It's going to take me just a little bit of time to copy this over, then I can explain what I'm trying to say here. Dot where has Indian is true, right? So this will give you the results. So if it finds one here, great. If the first one were to have returned true, then we would be in good shape because we wouldn't have to execute the other three. Or if this one returns true, we wouldn't have to execute the other two. But if the top three big turn out to be false, then you'll have to execute all the four queries here. What this means is each of this, when you're executing this in a layer that talks to your database, each of this is going to result in a query, right? It's independently a query. So if you have, I don't draw very well as you can tell, but I'm just going to still try it. So let's say you have your app server where you have your code running, and then I'm just going to make this trivial. Your topology is obviously going to be more complicated than this. The first one is going to make a round trip. If that fails, the next one is going to be made. If that fails, the third one, and then the fourth one. So it's 4 queries, and each of these queries, let's say if each of the queries took 30 milliseconds, it'll add up to 120 milliseconds for this single execution, right? Now keep that in mind, and then we'll just look at other options here. So I'm just going to close this, open another one, and then we'll just continue that discussion. Yep. So let's say that took 120 milliseconds. Now let's see how else we could have written this, right? So there's many ways to do it. I'm just taking a silly example of some sort and then trying to walk you through there. The next one is going to be something like this. I rewrite the query so it says restaurant.r. I'm going to say where cuisine is Chinese. Our zip code is 21111, right? Or if this is, and then the next one is, sorry, grocery store dot r has Indian is true. Our zip code is 21111, right? So did I close a bracket here? Okay, so we could have rewritten that this way. If we do rewrite it, so what we're doing here is we're checking to see, we're just merging those two, right? So restaurant.r, if one of this is satisfied, it's going to return true, or if that's not true, it's going to execute the second query here. What this means is it means this would have resulted essentially in two queries, and each of them, let's presume it takes there's no reason for it to take any longer. It theoretically could, but it wouldn't, and there's indexes and whatnot. And again, now I'm going to digress and I'm going to talk about other things, but just let's take ceteris paribus conditions, right? So that was 4 queries, this is 2 queries, and it totals to 60 milliseconds, right? So at this point we see a 50% gain already. We didn't do much, we just did a very simple tweak here, and we see a 50% increase in performance, right? We shaved 60 milliseconds off. Now, can we do better, right? And again, if you're in the same network, there's going to be no latency. But again, when you're deploying it to servers, you have no control over where, to a large extent, you don't have much control unless you're a really big company, and you can, again, most cases, you don't have a whole lot of control. So your servers are going to be in